Trig pre-college, unit circle. All right, guys. So the unit circle, the key is this is a circle with a radius of 1. And this is significant to us because you see this picture drawn here. When we have a radius of 1, if I turn this into a triangle, we know we do that for a lot of these angles. This is our x value down here, and this is our y value right here. Like that's how you get to a coordinate in the coordinate plane. As you go your x-axis, like a coordinate like 5, 2 would be to the right 5 and then up 2, something like that. And r here they're using to represent the radius of this circle. But we know the radius of the circle is 1. So what we get here is a triangle, a right triangle, with the hypotenuse of 1. And so unit circle means hypotenuse equals 1. But also remember, our angle is always from the origin when we're doing these. So our opposite side is our y value side, our y-axis side, opposite the angle. Our adjacent side is our x-axis here. And our hypotenuse is this radius of 1. So what you notice about, like, if you were to do sine being opposite over hypotenuse, well, that would come out to be opposite is y over hypotenuse is 1. And y over 1 is simply y. So what we come out with is that sine equals y. And on the other side, cosine being adjacent over hypotenuse, our adjacent is x over hypotenuse 1 is just x. And so you end up with cosine being x. So if sine is y and cosine is x, every coordinate on the unit circle that has x comma y, we can think of that as cos comma sine. Just like that. So you no longer need to think of points as x, y, you need to think of them as cosine. Now it's going to take a little bit of practice to remember that cosine is x and sine is y. I think instinctively we want to have sine first and cos second because of we say sine first and SOHCAHTOA and so on and so on. So just remember that cosine is x, sine is y for points on the unit circle, and that's exactly what this question was asking, that xy is equivalent to cosine theta sine theta. So that's what we're going to use to do the rest of these problems. Now, the rest of these get into the exact value features, and so let me give you the exact values of the key reference angles. So a 30-degree angle is going to have the point, and the way we get this is the x value of this 30-degree angle. Well, x is, let me write this again, xy is now corresponding to cosine sine. So cosine of 30 degrees, if you type that into your calculator, cos 30, you're going to get that 0.866 decimal, which you should remember is radical 3 over 2. And sine of 30 degrees is 1/2. So to find a coordinate at an angle on the unit circle, you do cosine of that angle and sine of that angle to find the x and y values. And that's exactly what this question was asking. And so the answer here is B. But let me give you the other ones that are important. 45 degrees, if you type in cos 45 and sine 45, you actually get the same thing. They're both 0.707, and that is your rad 2 over 2. Rad 2 over 2. And maybe we should write that up here somewhere, that, you know, the 0.866, that's the rad 3 over 2. And the 0.707, not negative, looks like a negative sign. Let me redo that. It's sloppy. The 0.707, when you see that in your calculator, it's the rad 2 over 2. And then the other one we really need to know is 60 degrees, which is the opposite of 30 degrees because it has to do with cofunctions and it's the other acute angle, but we'll get into that another time. But cos 30 is 1/2, sine 30 is your rad 3 over 2, your 0.866. And you just type this stuff into your calculator, you'll get all these values that I'm talking about, and that's the key here. Now, there are other angles around here other than 30, 45, and 60, but they're going to be references of those. Now, when it comes to 0, 90, 180, 270, just type it into your calculator. Type in cos 180, type in sine 180, and you'll get what you need. But when it comes to something like 120, 210, 300, we have to remember that they're going to reference down to one of these. Your x and y may be positive or negative depending on what quadrant you're in, but it's always going to reference down to one of these when we talk about exact angle, special angle features. So these are the three that you need to just really have memorized. And your calculator will tell them to you. It's if you forget them, but you should know them pretty much right away. All right, so this next question is saying that the coordinate here is rad 2 over 2. So they want to know, what is this angle? Well, rad 2 over 2 comma rad 2 over 2, that corresponds to 45 degrees. That's it. So the angle is 45 degrees. You just have to recognize that as 45 degrees. And we're in quadrant 1, so that's easy. All right, this next one. What do they tell us here? X equals negative 1/2. So they're telling us for this coordinate, x is negative 1/2. And they're not giving us a y value, but what they really want is, what is this angle? And so a couple of things. First of all, it's always a good thing, first time you're doing trig problems, think about what quadrant you're in. We are in quadrant 2. And let's see. Does that help narrow it down? Sure, that's not in quadrant 2, but these three are. All right, so we're definitely in quadrant 2. So now you have to think, when is x 1/2? Forget about the sign for now. Just when is x 1/2? And go back to your special 3 values. And what we're really saying is when is cosine 1/2? And so looking at our special angles here, x and cosine is 1/2 at this 60-degree angle. So that means we're talking about a 60-degree angle here. But we're in quadrant 2, so what we're really talking about is 60-degree angle here. 60 away from 180. 60 short of 180 is 120. And so that is the answer here, is 120. The reference angle for 60 degrees in quadrant 2. And we knew it was 60 degrees because that's when x and cosine have the half value. The sine here would be radical 3 over 2. Now, why is it negative? Well, because if we remember from our ASTC, that sine's positive here, which it is, but cosine's negative. So when you type cosine of an angle in here, you're going to get a negative value. Like if you type in cosine 120, you're going to get negative 1/2. And that's the other thing we really could have done here is x now needs to correspond to cosine. So when they say x is negative 1/2, that means cosine is negative 1/2. And I could, type in cosine of this, cosine of this, cosine of this, cosine of this. This is the only one that's going to give me negative 1/2. Now that's not a foolproof method though, because there are actually 2 spots that will give you negative 1/2, but it could definitely help narrow it down for you with a kind of guess and check in your calculator. But the other reason why cosine is negative here, because every coordinate here is negative x, positive y. And so that's another reason why it makes sense. Think about every point in here, like negative 5, 7, right? Negative x, positive y. So the approach was, in quadrant 2, cosine is 1/2. That has to be 60 degrees. And 60 degrees in quadrant 2 is a reference of 60 from 180. And so that had to be an angle of 120. Let's try another one here. This time they're giving us the angle, but they're giving it to us in radians, 3 pi over 4. And so I could convert this into degrees. I could think about it in terms of 3 times 180 over 4, or 3/4 180. And I think that's going to come out to be 135 degrees. Let's see, 180 divided by 4 is 45, and 3 of those is 135 degrees. And so this angle is 135 degrees. But what's more helpful than that is, how far are you from the x-axis? In quadrant 2, how far are we from 180? And 135 is 45 short of 180. And what do we know about the point at 45 degrees? it's rad 2 over 2 and rad 2 over 2. But in quadrant 2, you have to make sure that your x value is negative. Your y value is positive. Your cosine is negative. Your sine is positive. So what is the value of x? What is the value of cosine? Negative rad 2 over 2. If they said what is the value of y or sine, it'd be positive rad 2 over 2. And I think that's it. I think that's enough to get us started tomorrow in class. So I'll see ya.